Hi, and thank you for your great question. And I'm sorry for the late reply. I didn't see this one until today. Um, so your question is, you have sodium phosphate mixed with cobalt 2 chloride, and they want you to create the reaction equation and the products, and then say whether a precipitate occurs in the products or not. And you were wondering, in the solution for 7.19, it says to neutralize the subscripts. And I think you're getting it mixed up, neutralizing the subscripts with actually balancing subscripts. You were not really balancing subscripts. What we're doing is finding out the formulas by neutralizing the subscripts, and then we balance the whole equation. So let me show you what that looks like. First of all, we need to create our equation. We have our products, which are sodium phosphate and cobalt 2 chloride, and then our products are going to be, the sodium is going to go with the chloride, so we're going to have sodium chloride, and then we'll have cobalt phosphate. Oh, I've run out of room already. There we go, cobalt phosphate. So there it is in terms of the formula names. Now what we need to do is we need to give the actual formulas. So sodium phosphate, sodium is, the symbol is Na, and it has a positive charge. Phosphate is the polyatomic ion PO4, and it has a 3 negative charge. So when we go to get the subscripts, we just bring these down. It's going to be 3 sodiums to 1 PO4. And then to see that those subscripts actually neutralize this compound, you go 3 times positive 1 is positive 3. 1 times negative 3 is negative 3, and the positive 3 and the negative 3 do show that this is a neutral compound. Okay, so I don't really need to have this 1 here, so I'm just going to get rid of it. I'm also going to get rid of these charges just so that we don't make this more complex than it has to be. Now that's going to be added to the cobalt 2 chloride. So cobalt, the chemical symbol is CO. In Roman numerals, we have a 2, which means that it's a transition metal with a charge of 2. And then chloride means that it's coming together with a chlorine element, chlorine, and it has a charge of -1. Now to get our subscripts, we're going to bring these down. We're going to have 1 cobalt to 2 chlorine, and that neutralizes the subscripts because 1 times positive 2 is positive 2. 2 times -1 is -2. The positive 2 and the -2 charges cancel each other out, so we have a neutral compound. Okay, so that's neutralizing the subscripts. We're not actually balancing them, kind of balancing them, but not in the same way that we are going to later balance out this equation. Okay, now for the products. I have sodium and chlorine coming together to create sodium chloride. Sodium has a charge of +1, chlorine has a charge of -1. You bring those numbers down, it's going to be 1 to 1. That's balanced out. And then we're going to add that to cobalt phosphate. So cobalt is going to keep its charge of +2. So I should have put a 2 in here. And then phosphate is that polyatomic ion of PO4, which we know has the -3 charge. So what we're going to do is bring these charges down like that. 3 times +2 is +6. 2 times -3 is -6. They cancel each other out, so I know that I have my formula correct. Now that I have my formulas correct and my subscripts, I now need to balance out this equation using coefficients. Okay, so do your subscripts first to get your proper formulas for each of the compounds. Then once you have that, you can go back and now do your coefficients. So for my coefficients, I need to first count up the elements on each side. I'm going to do sodium first because it's the nonmetal. Then I'm going to do chlorine because it's a metal. I'm going to do cobalt because it's a metal. And PO4, the phosphate polyatomic ion, stays together on both sides. So I'm going to do it together. Remember, that's one of the hints they say when you are balancing equations, is that if you have polyatomic ions that stay together on both sides, to do them as a unit. There we go. So I'm going to go ahead and I'm going to count up how many I have. I have 3 sodiums on this side. I have 2 chlorines. I have 1 cobalt, and I have 1 phosphate. On my product side, I have 1 sodium, I have 1 chlorine, I have 3 cobalts, and I have 2 phosphates. So first of all, I am going to balance my sodiums. I'm going to put a 3 here. That's going to give me 3 sodiums and 3 chlorines. Next, I'm going to balance my chlorines, but I have a 2 here, and that's going to be hard to try and balance it to make it a 3. So I kind of skipped to cobalt for a second to see if I could maybe figure out from that what the coefficient can be. I have 3 cobalts on my product side and only 1 on this side. So this is what I did. I skipped chlorine and I just put a 3 here. That changed my cobalt count to 3 and my chlorine count to 6. That's okay. I'm now going to go back to my chlorine. I have 6 chlorines on my reactant side, so I need to get rid of this 3. I'm going to put a 6 here. That changes my chlorine count to 6. It also changes my Na to 6. Okay, I'm going to have to go back. I have 3 sodiums over here. I'm going to put a 2 here. 2 times 3 gives me 6. Everything's starting to balance out. I now have, though, because of that 2, I also have 2 phosphates here. And look what magically happened. My phosphates did balance out. So this is the balanced equation. 2 sodium phosphates plus 3 cobalt 2 chlorides will give me 6 sodium chlorides and 1 cobalt phosphates. Okay, so that's that part of the balancing done. The next thing I have to figure out is what my precipitates are. So both of these were aqueous, they were in solution. Then when they were combined, you see that their anions and their cation ions switched. So sodium went with chlorine and cobalt went with phosphate. If we use the solubility rules in table 7.2, we see that sodium is mostly soluble, and with chlorine it's definitely soluble. So it stays as aqueous. With cobalt and phosphate, phosphate is almost always insoluble, and with cobalt it is. So because it's insoluble, it's going to be the precipitate in this question. So the precipitate is going to be this cobalt phosphate. So lots to do here. Very, very complex question, but it is one of the end skills that you do learn at the end of this chapter. So great job. If you have any questions on this, let me know. Bye for now.